Class, let's look at this problem from the 8.6 homework set where we are looking at double angles and half angles for a specific angle that's given to us. Alright, so a couple things are important. Right here tells us that we are in quadrant 1. So those are acute angles, something between like 0 and 90 degrees. If you double that, you'll be somewhere between 0 and 180 degrees, depending on the angle. So this could be Q1 or quadrant 2, okay? That's important that we understand that. And then half angle, well, if we're in quadrant 1, 0 to 90 degrees, and we divide those numbers by 2, we're going to stay in quadrant 1. So this is going to be quadrant 1. So everything's going to be positive for our half angles. But our double angles, it depends on what we get based on this, okay? That is quadrant 1. Sine is almost 1. So we're right up here. So doubling that angle, something like almost 80 degrees is going to be something definitely in quadrant 2. All right, if it had been something less than 45 degrees, would have ended up in quadrant 1. So doubling these angles, these are going to be in quadrant 2 rather than quadrant 1. So in quadrant 2, cosine will be negative, tangent will be negative. Sine will still be positive, however. All right, let's see how we can do this. So if we know the sine, we know in quadrant 1 that the opposite is 15, and we know the hypotenuse is 17. So we can find the adjacent by squaring the 17, squaring the 15, and taking the square root. All right, 17 squared minus 15 squared is 64. So this is the square root of 64, which is 8. So now there's the triangle that we're dealing with. All right, to be able to do all of these sines, cosines, tangents, all of them, we're going to need the cosine of theta is 8 over 17. All right, we're also going to need the tangent, which is opposite over adjacent, 15 over 8. All right, part A, sine of 2 theta. That's 2 sine theta, cosine theta. That's our double angle identity. All right, well, we know sine is 15/17, and now we know cosine is 8/17. All right, your calculator can handle all of this. Just put it in exactly how you see it. All right, and then math, change it back into a fraction. Don't leave it as a decimal. So 240 over 289. All right, B was the double angle cosine. Now there's 3 different double angle cosines that we get. We get cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. There's all these different variations of it. We're given sine. Sine is 15/17. We know cosine now, so it really doesn't matter. But most likely I would use 1 minus 2 sine squared, just because I don't even need to do I would have never even needed to do the triangle if all this thing asked me was the question B there. So I could just use the sine. So there's how I'd enter it into the calculator, hit enter, again, change it into a fraction. All right, so now we're on to the half angle sine formula. So the half angle sine is plus or minus the square root of, it's either 1 plus or 1 minus the cosine over 2. 1 plus would be cosine if it was the half angle cosine. 1 minus is the half angle sine, which is what we need here for part C. We're doing the half angle sine. So we would have plus, because again, we're in quadrant 1, so dividing the angle in half is going to remain in quadrant 1. So everything's going to stay positive. 1 minus, the cosine was 8/17. So when I subtract 8/17 from 1, I get 9/17 over 2. All right, the square root of 9/17 over 2, the 17 comes down and gets doubled. So that'll be 9/34. And then I could write this as 3 over the square root of 34. But rationalizing the denominator, I would get 3 square root of 34 over 34. So there's the rationalized version of that half angle formula. All right, for part D, it is the half angle cosine. So again, I'm going to do the positive square root. This time, instead of 1 minus cosine, it's 1 plus cosine over 2. So instead of subtracting 8/17, I add 8/17 this time. All right, 8/17 plus 1 is 25/17 over 2. And then again, 17 comes down here, joins the 2, that'll give us a 34. So that gives me the 25 over 34. All right, the square root of 25 is 5 over the square root of 34, but just like before, we're going to rationalize. That's going to give us 5 square root of 34 over 34. Right, again, quadrant 1, so all this is positive. All right, and then E and F are the double and half angle for tangent. So tangent, the double angle formula here, is 2 tangent theta over 1 minus tangent squared theta. All right, so we got tangent is 15/8. Type all that into your calculator. Be careful in the denominator. You do need parentheses because we have subtraction down there. We got to put a parentheses 1. So I type it in like that. All right, it's going to be ugly decimal. I'm going to hit math into a fraction. So there's my answer, negative 240 over 161. All right, and then finally on part F, the half angle tangent formula is, again, tangent is sine divided by cosine. So it's the numerator for the half angle sine divided by the numerator for the half angle cosine. So that, again, it would technically be plus and minus, but because we are in quadrant 1, we're going to stay in quadrant 1, so it'll be positive. So once again, I could plug in these values for cosine, which was the 8/17, like I did before, but I've already calculated the half angle cosine and the half angle sine on C and D. So right here, when I had this 3 square root of 34, and then this one, the 5 square root of 34, dividing sine divided by cosine. This was sine, this was cosine. I'm just going to get those numerators. Just like any time that we do this and the denominators are the same, we can just grab the numerators. So 3 divided by 5 is my half angle tangent. All right, I'm going to show you a cool little trick you can do with your calculator here. So we are told sine is 15/17 and we're in quadrant 1. Since this is positive, the angle it gives me would be a positive angle if I used inverse sine. So what I'm going to do is second sine, that's inverse sine, of the 15/17. All right, that's my angle in radians. And so I'm going to store that, STO, store, and I'm just going to use alpha A, meaning angle, okay? So my angle is that many radians. Well, I'm going to double that, and I'm going to take the sine. So the sine of 2 times A is that number right there. Now we can check and see. A lot of times this won't be able to convert into a fraction because it's approximating it. But there it is, it did. So 240 over 89. All right, now cosine of 2 theta, so same thing, cosine 2 times the angle. All right, convert that to a fraction, and there is my negative 161 over 89. All right, I could do the same thing with my half angles. Take alpha A, divide it by 2, change that to a fraction, math 1. Didn't like it, so it wasn't able to do this. Now, why not? Well, the reason is because it was a radical, okay? So here's what you can do on that. Sometimes, again, you can't always, but if I square that, didn't like it. So let's see if it will convert that to a fraction. Yeah, it did. So there's 9/34. That's the squared value. So that's the 9/34 squared. So the square root would be the 3 over the square root of 34. So you can still play around with this and you can find out what these values are, the exact values, all with 100% the TI. You just have to be able to manipulate it. And so you have to know when you do the half angle formulas, because they have the square root in them, you would need to square the values you get when you plug in those half angle formulas to get a version of the fraction that is squared. So this is the squared fraction, so I would need to take the square root of the top and bottom and simplify.